topic that you're teaching?
I would say this is kind of the traditional gas laws unit for a chemistry class. So looking at the relationship between pressure and volume and temperature and N amount of molecules.
Mm-hmm. And what are some of the, well, tell me about how you've taught this unit in the past and how you think this unit is different this year.
Last year I taught this unit using a planned curriculum. It's called Living by Chemistry, and it's all centered, it has 5 kind of sections, but the section about gas laws is in a section about weather. Mm-hmm. So the whole kind of unit is about weather, and it focuses on gas and gas behaviors. And I thought that it wasn't very interesting for the students last year. Like, they didn't seem to really care about the weather, and it wasn't exciting. And so I felt like they weren't really into learning about that. And also I felt like they weren't, maybe because they weren't interested in it, they weren't doing a lot of reasoning about gases. Like, they just kind of learned some of the rules, like pressure and volume are related, but I don't know if they were really having to think much about it.
Mm-hmm. And you were also saying that you thought that the unit didn't necessarily help the kids make the links between all of the variables, mm-hmm. like pressure, volume, temperature, mm-hmm. That it just was harder to do in terms of the weather because it's sort of an open system for kids.
Yeah, and a lot of the sections seem very kind of disjointed. So we would learn pressure and volume are related, mm-hmm. and here's how, but then I don't think that they were ever connecting it to, and then also if I, like, temperature would have to stay constant, but if I change temperature, how might it change things around? So mm-hmm. I felt like they were never making a kind of a big picture. They mm-hmm. were only looking at little pieces of mm-hmm. things.
So sort of like in traditional textbooks, how they walk you through like the different individual gas laws.
Yeah.
Here's Boyle's and I don't know.
Yeah.
Gays. So it sort of walks you through them all, but it never really got to the bigger picture.
Yeah, I never felt like it got bigger. It was definitely just like, here's a lab about Boyle's law, and then here's a lab about Charles' law. Mm-hmm. And they had to collect data and make sense of that data and kind of look for a relationship between two things, but it never got bigger than that. Mm-hmm. It never kind of told the whole story.
Mm-hmm. Which allows the kids to understand for how gases behave in general.
They were never able to really kind of generalize, I don't think.
So tell us what you're doing differently this year.
Well, I guess I decided to try to look for ways that could help them make that bigger picture. Mm-hmm. And so we're going to start by looking at a tanker that crushes. So the story is the tanker that's steam cleaned, sealed up, and they come back in the morning and it's crushed. And I want the kids to try to explain why that would happen. And so to do a good explanation of that, they have to think about pressure differences and the movement of the molecules and temperature and how much stuff is in there and how much space it's taking up. And so they really have to start looking at all of those pieces and try to make sense of what's causing this tanker to crush. Mm-hmm. And to help them think about that, they will also use the soda can crushing activity to try to explain it kind of in a way where they can actually touch it and change it around and see how it's working. And the whole point of that is to get them to realize that there are these different variables when you're thinking about gases that affect the behavior of gases. So the pressure or the volume or the temperature or how much gas there is affects that behavior. And so it's kind of like getting them to the ideal gas law, the PV equals nRT, which you could just learn about, but I don't think they could make as many connections to what those things mean. So after we do that tanker and they make all those, kind of figure it all out, those variables, then I want them to use those understandings of the ideal gas laws to think about a car engine and how that works and kind of reason with those variables to explain how that car engine works.
So tell us more about the car engine
Um,
and how you came to choose that, and
Well, I think that, so like I said before, the weather unit was not very interesting to kids. And I think that something like a car engine is more interesting to students. And I know some of my students especially, I've heard them talking about cars and engines and things like that. So I want them to think about, like, if you're going to try to make your car really fast, how could you adapt your engine to make it better based on some things you can do with gases.
I think the other piece too is about how your small school actually has an engineering focus too.
So our school is a technology, engineering, and communication school, and so there are a lot of kids who are really interested in technology and engineering, and so kind of this idea of creating or designing the best possible race car engine, I think will be really compelling to a lot of students.
Mm-hmm. So let's back up a bit and tell me a little bit about, before this unit, what are the kids coming to? What do they already know coming into this unit?
Okay, coming into this unit, we did kind of another smaller unit on phase changes, really focusing on the kinetic molecular theory and how molecules are moving. They had to act it out, so they kind of have this physical idea of how the molecules move around. And we also did a thermometer investigation, so they thought about how matter behaves like how it behaves in different temperatures. And we looked at energy transfers a little bit too.
And so specifically they were plotting out?
Oh yeah, and we did a heating curve kind of investigation too. So they should come into the unit having a lot of ideas about phase changes, and they should already know a little bit about the idea that matter is made up of molecules, and those molecules are moving around, and they know a little bit about how different phases of matter react to temperature changes.
So what parts of their prior knowledge do you think they'll really be able to draw on well for this unit, and what parts do you think might be more of a challenge that you might need to support the thinking on more?
I think that they should come into it, like, I really feel like they know that a liquid becomes a gas, and so they kind of know what a gas is, and they should be able to think about gases expanding and contracting. I think that should be an idea that they come into the unit with. We never really talked about pressure in that unit, so I think it was maybe mentioned once, but it's not something that they'll come into the unit thinking much about.
Can you tell me a bit about the explanatory models that the kids will be using, and how you're helping structure those models for the kids?
Okay, so I think the first one that I'll be using is that tanker crushing. So trying to explain what's causing this tanker to crush, and to try to get them to think about as many things as possible. So to make them try to think about temperature and what's happening inside, that they can't see what's happening inside and what's maybe happening outside. And so I want them to try to explain as many of the reasons why that tanker is crushing that they can.
And so in this case, you're thinking of them actually drawing a picture of the tanker and then representing the gas molecules inside.
Yeah, I want them to draw it. I want them to draw what is happening inside and represent the molecules inside, and hopefully like a before and an after picture, so they can say, this is what's happening in the beginning, and now it looks like this because, and try to explain what's going on inside, and also hopefully outside that would make it crush.
And you're doing similar kinds of representations like that with can.
The can. So very similar. I want them to almost do the same thing with the can and explain, like, I put it on a hot plate and here's what I think is happening inside. Now I flip it over and it crushes. Here's what I think is happening inside. And so I want them to really try to draw it and use words to explain what they think is happening.
So what are the key pieces to that explanatory model?
Well, to really explain it, I think the students need to be able to tell me, it's kind of challenging because they have to say what changes.
Right.
So they need to tell me how the temperature change affects what's happening inside that tanker. And so they should be talking about that steam condensing to liquid because of the temperature change. They should also be talking about those steam molecules moving around and making collisions with the outside of the tanker originally, and then when it's being cooled, that those collisions are not happening as much because of that water or the condensation to water. And maybe also if there's still some steam, that it's just they're moving more slowly, the molecules. And then they should also be talking about pressure from the outside, so the air pressure around the tanker or the can, and how the balance of pressure between what's inside and outside is what allows that tanker to stay its normal form, and then when the outside pressure is more than the inside, what allows it to be crushed.
And then you're working them towards some other models too?
Yeah, so like I said before, the whole point of that is to really get them thinking about what affects the behavior of a gas. And so eventually I want them to really see that pressure affects the behavior of gas, that how much space that gas is taking up affects the behavior of the gas, how much gas there is, and the temperature. And so basically I want to get them to the ideal gas law, like the PV equals nRT. And so when we're reasoning about what's happening to the tanker, we're using all of those variables, or to any gas. And so that ideal gas law is also kind of a model of how gases behave and how we can explain the behavior of gases.
So part of this too is helping the kids now see PV equals nRT as another tool for reasoning with. Like they could draw the picture of it, but then they can also use the formula to help reason with how is volume changing and how does that affect temperature.
Yeah.
Because it affords a different kind of representation, or a different kind of way of understanding the relationships.
But I think a lot of times if you just get the ideal gas law, it doesn't make a lot of sense.
Right,
so
yeah.
Having something that you can use or connect it to.
And so you're really working up to that and sort of going to uncover that from the tanker. And then tell us about how you're going to turn around after that and what's the next sort of model that you're using after that.
So after that I want to work towards that explanation of how the car engine works. And so they need to explain kind of in an engine where is pressure and volume and temperature and the amount of air changing in that engine, and how is that affecting the motion of the engine. Also how they could change an engine using some of those ideas of compressing or cooling or things like that.
And that you're hoping that they'll use the PV equals nRT as a way to reason through the engine too. Were you also going to do like the tires too?
Yeah, so, I forgot about that. In the car, I also want them to think about, so not only for the engine of the car, but also in the tires, why you might want to have some sort of temperature sensor or pressure sensor based on this car being in different environments or racing and those wheels heating up and things like that. So another place to look for how those gas laws can affect, or how gases behave and how we can use those gas laws to explain that behavior.
Nice. So how are you going to help the kids go back to their models and add to their, or revise or clarify their models that they're working on?
I think that will be, I'll be able to do that really well with the tanker thing, because they will have started by drawing their model, and then they'll have some data that they'll collect when they're doing their can experiment, and each group will have something to add to that. And so that will help them add to that tanker explanation. And then I'd like them to do some reading and more investigation about pressure. So I'd like them to add their ideas about pressure once they've learned about that more deeply to their model. And then finally, once we look at all those variables that relate, they could also use the ideal gas law to explain or kind of link that with their model of the tanker.
And so, what are you thinking that this after this first round of working with the tanker and the gas cans, what are you thinking that they'll be able to put on their model, and what won't they be able to put on their model?
Well, to start with, their very first time, I think that groups will be in all different places. I'm not sure what they'll be able to put on it, but then as they do the investigation with the can crushing, they should be able to add something about, I mean, they can see steam coming out of that can, so I would think that they could say something about that steam or gas being produced, and they should be able to say something about that temperature change and how it affected the can or the tanker. And some of them should probably start thinking about about pressure differences and how that could cause the crushing.
And you're also thinking that maybe they'll be able to reason with a phase change in there too?
Yeah, they should be able to, since they're heating that can up, they see the steam, so they know that that steam was created, and I would hope then they also say that when they flip the can over that the reverse happened, that the steam would go back to liquid.
But then you're setting up a separate set, in your unit, you're setting up a separate set of pressure experiences and readings for them. Is that in anticipation that they're going to struggle with the pressure component?
I think that will be the hardest piece for them to just add to their model based on their own kind of thinking. That especially the external pressure, I think, will be something that a lot of students probably will struggle thinking about, like how could air, just this air that we're in, be crushing this can?
Yeah.
And I think also that kind of pressure difference will be challenging for some students to think about.
And what causes a change in pressure on the inside, or how could even a phase change, how is that related to a change in pressure?
So making the connection, I think, will be challenging for some students.
Nice. You know, we talked a little bit about like what prior knowledge the kids will be drawing on. Are there how else do you think you'll be drawing maybe more on their experiences that they're coming in with?
Yeah, I think from the previous unit they have some knowledge that they'll think about, but also, like, I think students have done things like squishing cans and water bottles, and so I think they have some ideas of how pressure works, but also gases and I guess breathing. They breathe and they kind of think about bringing air in and out, so they have that experience, and I think probably some of them have experience with car engines and that. I'm not sure if they've ever spent time really trying to explain how a lot of those things work, but they have some experiences with them.
So along those lines, are there some language practices that might be unique to this particular unit? And how do you plan to help your kids with that? And like, are there any symbolic or mathematical practices, probably using the equation a little bit too? And then are there any just more general scientific practices like theorizing or generating evidence-based explanations?
Yeah, I think that the proportional reasoning is like a big kind of important idea in gas laws, and I think it's often the focus of most gas laws units is just like, if I do using the equation and holding things constant, but I think it's really important for that, using the ideal gas law as a model, to be able to do some proportional reasoning, thinking like, if I hold one thing constant, what's going to change, and even how does one thing affect another thing? If this one goes up, does this one go up or down, or things like that? So I think that will be important for students to understand, and might be challenging. And then what I know will be challenging is having them try to generate a scientific explanation for something they can't see, because they can't see a lot in chemistry, and I think that's why chemistry is often challenging for a lot of people. But it's also, I know in chemistry, a lot of people do well because they can just memorize some rules. And I want them to do more than that. I want them to really try to think about what's happening and try to make those connections and explain why certain things happen using what we know about the behavior of gases.
Mm-hmm.
And so I think also as they try to explain what's happening to the tanker or to the can or even in an engine, I think that they will probably also have some problems connecting, like what they trying to say why they think something is the way it is. I think they would have an easier time just saying what they think is going to happen instead of like trying to really explain why they think that's happening.
Have they had much experience generating explanations in your chemistry class?
Not too much. We have done a unit about smells, and we've really tried to explain why different molecules would smell differently, including like a model of how that smell gets into the nose and how that smell why it smells, or kind of like how we interpret the smell. But we haven't done a lot of really deep thinking about explanations.
So let's talk a little bit about how this unit will help prepare them for understanding chemical reactions.
Well, I think it definitely connects to some of the things we did before, like the kinetic molecular theory, and they should be able to explain how gas behaves, and they should have some proportional reasoning ideas, which all kind of answer the bigger question of how does matter behave. But I think that it should help them, like when they start doing chemical reactions, to think about what is this thing that I'm calling a gas? Why does it even matter that it's a gas, and how might it react? I think that having some understanding of that will definitely help them think about more things that they can't see, like chemical reactions.
Yeah, and all those rearrangements of molecules, and whether it's a gas or a liquid or a solid makes a big difference in those reactions. So could you tell us what your essential questions are for this unit?
Well, I would say there's kind of the main idea is how do gases behave in a predictable way? But and then to start off the unit, I want a question to be just why did that tanker crash? Also, how can we explain how an engine works based on our understanding of how gases behave, and how can we capitalize on the behavior of those gases to make an engine work or make other things work, so kind of the engineering.